Am I standing in the middle of a field of living artifacts of indigenous use of Agave Utahensis? I believe, and I've just recently published some research that I think starts to prove that a lot of these Agave Utahensis plants and clonal rings that are around me right now are actually hundreds potentially of years old and date back to the time of indigenous, large-scale indigenous harvesting and roasting of Agave Utahensis. So I just published a paper in the Cactus and Succulent Society journal, which is a long-running, really important journal, academic journal for research papers and other kinds of papers and articles about cactuses and succulents. So I'm really, really honored to have also published in the journal. And my paper is basically about Agave Utahensis clonal rings, which there's a whole bunch of them around me right now, and indigenous practices, how indigenous folks, the most recent group being the Southern Paiute in the Southern Nevada area, how they utilized this plant, how they roasted it, and then how, but more specifically, how they managed their harvesting of it, because it was, very large scale harvesting that went on for hundreds and thousands of years in this area, and they don't seem to have hurt the populations. The populations there's tens of thousands of plants surrounding me right now, and it's a very healthy population with a lot of genetic diversity. And so that's what my paper is about, and that's what we're talking about in this video is, clonal rings and the harvesting practices and the history of Agave Utahensis harvesting by indigenous groups in Southern Nevada. Like most species of Agave Utahensis can reproduce in 3 different ways. One is through bulbils, which are basically small plants that grow directly off a flower stalk. That's fairly rare with Agave Utahensis and only generally happens in cases where the flower stalk has been damaged. The other 2 methods of reproduction that Agave Utahensis uses are much more common. The first one, of course, is to flower. It's a monocarpic plant, so it flowers once in its life and then it dies. And when it flowers, it puts up this giant flower stalk, 10, 15 feet, something like that, in a single season, produces flowers, the flowers get pollinated, and then they produce seeds like a normal plant. And then the plant dies and dries up. Now, the other way Agave Utahensis can reproduce, and in fact, this is probably much more common, the most common way that Agave Utahensis, particularly in habitat, reproduces is vegetatively, that is clonally through creating pups. Those are small plants that grow out of the base of a mature Agave Utahensis plant, and eventually enough of those offsets form that the plant turns into what we would call a clump. So here's an example of a single, I'm not sure that we would really ever call this a clump of Agave Utahensis, but this is a single plant that has started to produce offsets. There's one right there, and then as I rotate around to the other side, there's 1 or 2 over here on this side as well. And you can see that's how the clonal ring shape starts, right? A single plant like this will start to grow, and as it matures, it'll produce a ring of pups around its base. You can kind of see there's one right there that's a little shielded from everything. There's another one down there. There's another little one. Eventually, those pups, those offsets, will grow into plants of their own, and this thing will become a solid clump. And then when that central plant matures and is old enough, it will flower, dry up, and die, and that clump will start to hollow out and turn into a ring. So in a lot of its habitat, as you probably know, Agave Utahensis grows, in cracks out of hard, in this case, limestone boulders, and its clumps, while it does produce offsets, the clumps don't get really that big because they just don't have that much room to expand, because as you can see, this is a clump in an otherwise solid rock face. But then, in some parts of its habitat, particularly where I'm at right now, a lot of it is actually growing in what's called mala soil. Now, mala soil is a very organic material heavy soil, mostly mixed with gravel here. And as you can see, in areas where the cracks are bigger or where the plant is growing, just straight out of the mala soil, the clumps can expand as they age. And that's the characteristic of this habitat, this specific habitat that allows Agave Utahensis clonal rings to form. And so in environments where Agave Utahensis is growing in a loose substrate where it can form larger clumps, generally the process of creating a clonal ring is as follows. Basically, an individual Agave Utahensis plant will start to grow. Maybe the seed blew into the area and it's germinated. And eventually that plant will mature and start to create a ring of offsets around its base. And now those offsets themselves will start to mature and produce their own offsets around their bases, and thereby creating what we call a clump. Now at some point that's central, the oldest plant will flower, die, and dry up, and so that clump will start to turn into what basically looks like a ring with a hollow center. In my many visits to Agave Utahensis habitat and populations, I've seen a ton of these clonal rings. In fact, most of the Utahensis plants I see occur in either clumps or large clonal rings. And some of these rings are actually super duper big and super duper old looking, which raised a question in my mind: exactly how old are these clonal rings? And in fact, I know that there are other species of plants in the desert, like creosote for instance, where they can have clonal rings that are thousands and thousands of years old. So that question, how old are Agave Utahensis clonal rings, is what sparked the research that led to my publication in the Cactus and Succulent Society Journal. Because I went and I looked at the existing literature, I looked at all the experts who'd written about agave and Agave Utahensis, and I could not find anything definitive that had yet been written about dating and figuring out how old Agave Utahensis clonal rings were. So I realized that if I wanted to answer this question, I'd have to do the research myself, and that research started with a survey. So the survey I conducted across 3 different sites where there are dense stands of agave near, and by near I mean either physically adjacent, like right next to, or a few miles away, certainly within walking distance of archaeological sites, namely agave roasting pit sites. And these 3 sites, I intentionally obfuscated their location in the paper. I explain a little bit about them, I describe them a little bit, but I don't tell you where they are, primarily just to protect both the archaeological sites and the plants located at these sites, the Agave Utahensis plants located at these sites. But the 3 of them are, quite near the old Spanish Trail here in southern Nevada, typically home to Agave Utahensis nevadensis plants. And at these 3 sites, I surveyed 96 different Agave Utahensis clonal rings. And when I say I surveyed, what I mean is I looked at them, I put down a tape measure next to the plants on the ground, and then I took an overhead high-angle photograph of each one of these clonal rings. And then when I got home, I went through these clonal rings, these photographs of these clonal rings with the tape measure and the photos on my computer, and I used that tape measure to then measure the longest, or my estimation of whatever the longest diameter of these clonal rings are. From the longest diameter, I found the longest radius, essentially half the longest diameter. That is the distance from the center of the clonal ring to the edge of the clonal ring. And I did this because what that would imply is that if the oldest plant was in the center of a clonal ring or a clump of Agave Utahensis plants, then the longest radius is essentially how far out, how many inches or centimeters, if you're so inclined, the clonal ring had grown over time. And I used that, I based my size-dependent dating methodology on that longest radius measurement. Now, an important thing to note about my survey is that I didn't use a statistical sampling methodology like a plot or grid or anything like that, because my goal was not to come up with an overarching description. I wasn't trying to say something like, the average age of an Agave Utahensis clonal ring in these populations is X number of years old, or the average size of a clonal ring is this size, or anything like that. Rather, what I was actually trying to do is come up with very demonstrative, descriptive, illustrative examples of Agave Utahensis clonal rings at each stage of their development. And I actually identified, out of these 96 different clonal rings that I surveyed, a number of different clonal ring shapes. And those shapes are, and I have a whole video, I have a couple more videos coming that are gonna delve into a specific part of the paper in more detail. And one of those videos that's coming is gonna do a deep dive into the agave clonal ring shapes that I identified. But just as an overview, the youngest shapes generally that I found in my survey of those 96 clonal rings are what you would call solid clumps. Basically, there's a plant in the center, it's produced a ring of offsets around it. Maybe some of those have also started producing a ring of offsets, but the clump is young enough that the central plant, the oldest plant, hasn't flowered, died, dried up, and then, been blown away or desiccated into the desert soil yet. And then you have the next oldest Agave Utahensis clonal ring shape are partially hollow rings, right? So that solid ring has gotten old enough that some of the plants in the center have actually flowered, died, dried up, and then been absorbed or blown away into the desert. So part of the center of that clump is actually now hollow. And then the next oldest is actually just hollow rings, where most of the center, or every plant in the center, have died, dried up, and disappeared. And so rather than it being a solid clump, now it is actually a ring, right? Where it's got a full ring of plants around the outside, but the center is empty. And then eventually the next oldest shape that I found are what I'm calling broken rings, or U shapes, right? At some point the ring keeps expanding and expanding, and part of it breaks open and creates sort of a U shape. And in the video, I'll detail a little bit more about why the U shape is generally the shape that it takes at this stage. And in fact, there's some interesting patterns to where if the clonal ring is on a hillside, the open side of the U will be facing up the hill. And in the clonal ring shape video, I will detail a few potential reasons why that is. And then the next oldest shape, in fact, the oldest shape, generally speaking, that I found in my survey is what I'm calling a broken ring. So at some point, you know, the ring keeps expanding and expanding, the top is broken open into a U shape, and then the rest of the ring starts breaking apart. And now basically what you have is, instead of one sort of concrete, continuous ring shape, clonal ring shape, you now have what appear to be individual chunks, individual clumps. And that's why this is the hardest shape to identify just visually, because at what point is it, these are two separate clumps, or are these a broken ring? So the broken rings that I found in those 96 clonal rings that I surveyed were generally the oldest shapes based on their size. It's possible that I missed some clonal rings, the broken clonal rings that are very open and very, very old. In fact, it's very likely that that's the case. And I missed some of the oldest in these habitats. But of those populations, of the plants that I've looked at, like I said, I developed what I'm calling a size-dependent dating methodology. So, like I said, I surveyed the plants, I took pictures of them with measuring tape essentially next to them. I used those photographs to measure a longest diameter, and then took half of that and the longest radius. And remember, that's essentially the distance from that center, that oldest plant, how many inches of offsets have grown. And then from there, to derive an age of that clonal ring, we have to make two assumptions. The first assumption is which size, how big is each individual rosette, is each individual plant when it flowers. And based on the photographs that I took, I'm estimating that somewhere between 4 and 5 inches is the actual ground space taken up by an Agave Utahensis, the average Agave Utahensis plant in habitat when it flowers. And so if we say that, say I found a plant where a clonal ring where the longest diameter was, let's say, 40 inches, right? And then we look at half of that, that's now 20 inches longest radius. If we estimate that the average rosette size at flowering is 4 inches, we divide 20 by 4, and we find that basically that means that there's been 5 generations, right? 5 plants have grown. There was a center plant, and then there was 4 additional plants that grew out from there, or approximately 4 additional plants that grew out from there. So we can assume that that's basically 5 generations of plants. Now, if the plants actually turn out to have more like a 5-inch average size at flowering, then of course that math changes, and we're looking at a 4-generation clonal ring, based on a 20-inch longest radius. And in my paper, I present my findings using both of the estimations, both of the assumptions, this average size at flowering, and then the other one that I'm going to talk about in a second, but I present them as ranges. So I give, here's the estimates of the ages of the plants, of the clonal rings, if the average size at flowering is 4 inches, and here's the estimation if they're 5 inches at flowering. And then the other assumption that we have to make, once we have an estimated number of generations, and that's based again on the longest radius and the average size of flowering, is to turn that into the number of years. How old is this clonal ring in years? And to do so, we have to make a guess, an estimation at the average age of flowering for each of these individual plants. So if we have 5 generations of plants in a clonal ring, how many years does that represent in terms of growth? So to estimate the average time it takes an Agave Utahensis in habitat to flower was really complicated. There is no existing literature. There's a bunch of citations, like 80 citations or something like that in my paper, but I did not find any that had any sort of significant study of, habitat Agave Utahensis plants and how long it took them to flower. So what I did find is a few anecdotal cases where there were some plants in cultivation cultivation that had flowered. But of course, cultivation is very different than habitat because, you know, there's more water and nutrients and stuff like that. I also spoke to a number of experts and just kind of asked their gut feelings, either folks you would know that I've interviewed and stuff, and you know, other folks that are experts on agave, and particularly Agave Utahensis in the field, and what they, you know, what do you think? I asked them, what do you think the average age of flowering? How long does it take an Agave Utahensis in habitat to flower? And then I looked at some other, you know, related agave plants. For instance, Agave deserti, which is a similarly sized and roughly, you know, geolocated, like in the same general area. It's one of the closest to Agave Utahensis. There is some evidence, there is some literature that suggests there's like a 40 or 50 year average time of flowering for Agave deserti, which is super long for an agave species. Tequila agave and other forms of agave that are harvested for mezcal and products like that, some of them have flowering times under a decade, so really quick flowering times. But Agave deserti, again, in some cases in the literature, there's 40 or 50 average years at flowering. And then there's even, you know, cases where there's individual plants that have been seen to have grown for 70 years before they flowered. So combining all this together, I think that's a safe range, a safe estimate to say that Agave Utahensis in habitat flowers at something like 10 to 20 years old. That's a pretty big range, and it's also very possible. It's highly unlikely that they flower on average much sooner than that, because that would be a sort of rarity in the botanical world or in the agave world, and we'd probably have some evidence of that, and there would probably be some study about that. It is possible, though, that the average time of flowering is longer, is either on the high end of that, closer to 20, or even beyond that, because again, related plants like deserti have much longer, have like twice as long average age of flowering. But if we assume 10 to 20 years, we have another range of assumptions that we can apply to that data. So again, if we find that we have a 5-generation-old Agave Utahensis clump, and say, you know, it takes 10 years for each of those plants to flower, you know, we're looking at something like a 50-year-old clump. If it takes more on the long end, we have, you know, it takes 20 years for that Agave Utahensis plant to flower on average, we're looking at more like a 100-year-old Agave Utahensis clump. So what's really interesting is that when we start looking at the 96 plants that I surveyed, and we start looking at some of the biggest ones in that and applying this size-dependent dating methodology, it pushes us back into the range of well over 100 years, in some cases close to or over, again, depending on the assumptions and all that kind of stuff, over 150 years, and that puts us into a really interesting time historically. And to understand why that's a really interesting time historically, we need to go back and understand the historical context of indigenous use of Agave Utahensis. So I'm out here at one of the sites that I surveyed, or near one of the sites that I surveyed, and behind me you see a really good example of an agave roasting pit. Now, there are a number of roasting pits in this area. In fact, there's a site that's a little bit that way. I don't want to be too specific about where I am, but and in that site, actually, there's been a bunch of studies done, and lithic debris, that is basically debris from making rock tools, has provided archaeologists and researchers evidence that pits like these have been used for thousands of years, something like 7,000 or 5,000 years. And in fact, the most recent indigenous inhabitants of the area, the southern Paiute, were likely using roasting pits like this for at least 700 years. And basically what they would do is they would send a big party up into the hills you see behind me and all around here. They would harvest Agave Utahensis, chop off the outer leaves of the rosette, and then place them into this pit along with some limestone, a fire, and then cover it over, and then roast those hearts for a few days until the hearts got tender and delicious. And then they would eat a bunch then, and then you could make them into basically cakes that would last. And they did this in the springtime, mostly because that's when the agave were ripe. But the springtime is also a really important time for food stores for populations of indigenous folks that hunt and gather food, because that's when, you know, there's a lot of big game in the wintertime, but by the springtime, you know, their crops haven't grown yet, like the crops that they're gonna plant and stuff, corn, etc., haven't really ripened yet, so they can't eat those. And then the big game that they were hunting in the winter has kind of run out by the springtime. So that they had some food like Agave Utahensis in the springtime was super duper important. And so basically what you see behind me, like I said, is a roasting pit, and you can kind of see that it looks different than the ground around it, because you can see these sort of white-ish stones mixed in with much darker soil. And that soil is basically biochar that's been built up over hundreds and thousands of years of use of roasting agave and other things like prickly pear opuntia, which you can see. I don't know if you can see it in the camera, but there's one growing down in the middle of there. And then the white stone is actually fire cracked limestone. You see, limestone, which is abundant in this area, holds heat better than any other stone here. And so when you use it in a roasting pit like this, it allows the roasting pit to stay hot for a lot longer, but you can only use it once, because once you use it that one time, it gets white and it cracks and it doesn't have its thermal properties anymore. So in a lot of areas, in the other parts of the Southwest where agave roasting was prominent, the ability to have enough wood, trees essentially, around to light a fire this size and keep it going for a couple of days was kind of a limiting factor in agave roasting, alongside availability of stones like limestone. Because in a lot of places in the desert Southwest, agave grows in much lower elevations and in much more arid areas. But up here in the pinyon juniper woodland, as you can see, there is a bunch of trees around me. So here, the presence of wood was not such a limiting factor. And so again, this is one of the best examples of an agave roasting pit in this area. One of my favorite examples. It's still really, really deep, again, because it was used for hundreds and thousands of years. And in southern Nevada, indigenous folks, humans have lived in the southern Nevada area, the Las Vegas area, for probably at least 10,000 years. There are sites in a place called, or there's evidence in a place called Tule Springs in, basically North Las Vegas here, that shows that humans have been around in this area for about 10,000 years. But I don't, to my knowledge, know that there's any agave utahensis in that specific area. Near the sites that I actually surveyed, however, there is lithic debris and other archaeological evidence. Lithic debris is basically, lithics means stone or stone tools. And so the debris is like when you're making a stone tool, you're chipping off pieces of the stone, and the stone that's on the ground, and then other pieces of stone tools, and there's pottery and ceramics and things. And that kind of evidence has been shown by archaeologists, again, in the sites that I surveyed, in some of these 3 sites that I surveyed, that humans have been in that area using those roasting pits for something like 7,000 years. Right, 5,000 BCE is some of the earliest evidence of use of agave, or of use of those sites that include agave utahensis roasting pit, or agave roasting pit. So while there's no direct evidence, of course, because I don't think agave utahensis remains are really going to last in the desert for 7,000 years, that these sites that include agave roasting pits have been used by multiple groups over the course of, at least since 7,000 years ago, is pretty strong evidence that agave utahensis has been used for thousands of years. And when we look at the individual groups of indigenous folks that used those sites, that we know used those sites, back at the 7,000, 5,000 BC area, there's a group that we call now the archaic desert culture. We don't know a ton about them. What we do know about them comes a lot from, like I said, the lithic debris and the lithic, the stone tools and stuff that they left behind. But they did likely use agave utahensis based on their use of these roasting pits. And then the 2 most recent indigenous inhabitants of southern Nevada, of Las Vegas area, of these sites that I've surveyed, one is an ancestral Puebloan group called the Virgin Anasazi, and they moved into the area at about 800 CE, so something like 1,300, 1,200 years ago or so. And they definitely used these agave roasting pit sites, but the next group used them probably the most prolifically, and that group is the most recent indigenous inhabitant of southern Nevada, of these sites, and that's the Southern Paiute. Now, the Southern Paiute is a Numic-speaking people. That's their language group. Numic is a language group, an indigenous language group, and there's something called the Numic spread hypothesis, which basically postulates that these folks came from Owens Valley in California and then migrated eastward into the Great Basin and the Colorado River Basin, and potentially displaced a lot of the earlier inhabitants, like the ancestral Puebloan group, the Virgin Anasazi that I mentioned. And part of the reason that they were able to displace these folks and built up such huge populations is that they actually relied a lot more on the processing of smaller gathered plant food sources, so like pine nuts and agave utahensis. And so they moved into the area, the Southern Paiute, this Numic speaking group, moved into the southern Nevada area and started using these roasting pit sites about 1,000 years ago, roughly 1,000 CE. And they stayed there, and again, they were the most recent indigenous population. And then so around about in the 1700s to sort of mid to late 1700s, Southern Nevada eventually became the site of the Old Spanish Trail, which, as I mentioned, these sites that I surveyed are very close to the Old Spanish Trail. The Old Spanish Trail, of course, was important for Spanish explorers and Europeans, the first Europeans that came into the area that were exploring and trapping and trading and then traveling to the West Coast. Eventually, around about the middle of the 1800s, the Mormons started settling, and they were some of the first European or white settlers to the Las Vegas Valley. And by the middle of the 1800s, the United States government assumed control of a large chunk of land that included Southern Nevada. Now, when some of the first Europeans came to the area and met some of the Southern Paiute, there are reports that there were, and I detailed the oral history and the ethnographic data about this, but there were reports that were probably like tens of thousands of Southern Paiute living in this area, living a traditional lifestyle, and a large part of that traditional lifestyle was gathering and roasting and eating Agave Utahensis. But when the Mormons settle in the area, the U.S. government takes control of it. Their lifestyle came to an end. That hunter-gathering lifestyle came to an end very quickly and very abruptly, so that by 1880 there was something like 90% less Southern Paiute living in the area, and those traditional lifestyles were done with. So any large-scale Agave Utahensis harvesting was probably done by, at the latest, 1880, and probably more like 1850. So somewhere in that range is the end of large-scale traditional indigenous harvesting of Agave Utahensis. Something like, approximately 150 to 130-ish years ago. And now that's why I say that the age of some of these clonal rings, where they are pushing, they're certainly over 100 years, and some of them are pushing or maybe even older than 150 years, is really interesting, because that means that some of these clonal rings were around or were getting started during that period of large-scale Agave Utahensis harvesting. So they are in fact living artifacts of the indigenous resource management that was practiced by the Southern Paiute and earlier groups on these populations of Agave Utahensis. And I just think that's super duper fascinating. And that resource management is, I think, really, really interesting and an important takeaway, and kind of why I wanted to write this paper in general, because if you look at agave that is harvested, again, for tequila or for mezcal or other products in Mexico, like the wild harvested plants are being decimated by just a few decades of large-scale harvesting, right? And in the case of tequila agave, the genetic diversity is falling apart, because it's basically, they're monoculturing these things. They're not letting them go to seed, and it's just, the genetic diversity of a lot of these mezcal and tequila agave are being demolished, as well as actually just their sheer numbers. They're being pushed to the brink of extinction, and certainly many of them are actually threatened. And I detail a bunch of that in the paper as well. But in the case of Agave Utahensis, when you go out and you visit these populations today, many of them, particularly in these areas where they had been harvested for hundreds of years, the populations look very, very healthy. There's a ton of genetic diversity. That's one of the things that everybody talks about when they go see Agave Utahensis for the first time, is just how much genetic diversity. You can look at one plant and the next plant over from it looks entirely different from it. And in fact, they were hot, there was a large scale usage of them. Again, the Southern Paiute moved into the area about 1,000 years ago and didn't stop large scale harvesting of Agave Utahensis until something like 1850 or 1880. That's 800-ish years of large-scale Agave Utahensis harvesting, and large-scale on the scale of tens of thousands of Southern Paiute that Agave Utahensis formed a large basis of their food supply for generations, for 800 years. And before that, for thousands of years, for earlier indigenous groups. And so when we actually want to learn, okay, so what did they do? What resource management techniques did they have that allowed these populations to be used at such a high level, but not be demolished, right? Not be destroyed like the mezcal agaves are in Mexico after just simply a few decades of wild harvesting. And thankfully, we have a bunch of ethnographic data. Basically, in the earlier part of the 1900s, there were a number of researchers that came and talked to elders in the indigenous community, in the Southern Paiute community, and asked them, hey, how was Agave Utahensis used? They asked them about a lot of other things about their traditional lifestyles, but they also asked how Agave Utahensis was used. And there is a bunch of evidence and a bunch of data on the usage of it. And of course, different groups and different tribes in the areas that are around the desert Southwest use different agaves and use them in slightly different ways, but when we look specifically at how Agave Utahensis was used, we find a number of similarities. So one of the first things to understand is that there was no ownership of specific Agave Utahensis plots. They were communally owned, right? You know, anybody could go harvest agave from anywhere that they wanted to. However, the first most important indigenous resource management knowledge piece or protocol that was put into place is that the harvesting process was overseen by a central specialized authority. And different groups had different rules about who could be that authority, but there was almost always a single central authority who oversaw harvesting. Another thing is, and this central authority, this singular authority, ensured that these next two things were true, is that they were harvested at the perfect time in their life cycle, right? So they were harvested when they were ripe. And what that means for human consumption is that throughout its life, Agave Utahensis is storing energy in its rosette, but it's storing it in the form of fructans, which are carbohydrates that a human can't digest. And when it starts to flower, however, in the last year of its life, it converts those starches into simple sugars that are digestible for humans. It's doing that. The agave is not doing it for humans, obviously. It's doing it to power the giant flower stalk and to produce all the nectar that it needs to attract pollinators. But once that flowering process starts, those fructans, which are not good to eat, turn into simple sugars, which are good to eat. And if you wait too long until the flower stalk has grown tall, then the sugars are all used up. So the plant's not as good anymore either. But so they harvested, there was a central authority, and they harvested in the springtime, right as the plant started to flower, and they only harvested plants that had started to flower. So beyond it just being ripe for human consumption, the important thing from a resource management perspective is that that provides the optimal, the maximum amount of time for each individual plant to have produced as much as it could vegetatively, right? If you harvest a plant, like some mezcal plants and tequila plants are harvested way before they're gonna flower, which reduces their sugar content, which is, makes for sort of lower quality distillate. But it also means that those plants aren't going to reproduce vegetatively as much as they could have. With Agave Utahensis and the indigenous uses of it, those plants had their entire life to produce offsets, and that's how you get these clonal rings. So that they were harvested in the spring, they had central authority, they were harvested at the right time when they had time to reproduce vegetatively. And then third, the specific way they were harvested is really important as well. And again, that central authority, that central expert, that overseeing person made sure that they were harvested the right way. Basically, a stick with a sharp flat end like a chisel was pried into the base of the rosette, and then the plant was sort of dug up, separating it from its root system and separating it from its offsets. And they did so to make sure to both leave the root system in place and the offsets in place. So again, they were allowing the plant to produce as many offsets and to reproduce vegetatively as much as it could, and they were also allowing those offsets to live on, such that when they came back the next year and the next year and the next year and the next year for 800 years or thousands of years, those agave stands were actually still there and were still able to produce. Now, I'm gonna go into in a future video, in one of the next videos coming up, into more detail on this ancient harvesting or this indigenous harvesting practice, because it's really interesting that if you're familiar with Agave Utahensis propagation, there's a modern method that we call coring, that is where damage is done to the apical meristem, to the center of the plant. Damage is done to that, which induces the plant to produce more offsets than it would otherwise. And I think that harvesting technique where you're just basically popping out the central meristem, popping out the central rosette, may have the same effect. It may actually induce more offset propagation. But again, for more details, check out the paper or the video that's coming up soon. Make sure you subscribe to the channel if you're not already. But the video that's coming up soon on Agave Utahensis harvesting. And so again, I have at least 3 more videos coming about this topic, about my paper. We're going to talk about the Agave Utahensis clonal ring shapes that I discussed in more detail. I'm going to do a deeper dive into the actual size-dependent dating methodology, how I'm aging these Agave Utahensis clonal rings, and go deeper into that, into the math behind that. And then I'm going to talk more about this specific harvesting, because I think that's really, really fascinating thing to learn about. So this is actually the cover of the Cactus and Succulent Journal. Again, the Cactus and Succulent Journal is almost 100-year-old publication. A lot of the most important papers that I've ever read about Agave Utahensis and cactuses and succulents in general have been published in the pages of this. So it's like a huge honor to me to be able to have a paper that I wrote actually published in it. You know, you can see the article in here. There's lots of diagrams and graphs and photographs. And like I said, there's like 80 citations. So if you want to read more about all this stuff, you know, definitely check this out. And actually, I'll link in the description to a page on my website where you can download the PDF of the article if you're not already subscribed to the Cactus and Succulent Society Journal. Definitely subscribe though, support it. It's a great organization, great publication. The editor, Peter Breslin, is amazing. Thank you, Peter, for all your patient help with publishing my article. But yeah, if you want to check out the link in the bio or in the description down below the video, there's a link to where you can download the PDF from my website if you didn't get the hard copy of it. But again, please get the hard copy and support the organization. And I'd love to hear from you down in the comments. What did you think about the paper? Is there anything more you'd like to learn about it, about the topic of Agave Utahensis Indigenous Resource Management? And thanks for watching.